Hello student, today we are going to start the Fourier transform. Before to start the Fourier transform, we should know some basic formulas such as integration e raised to x sine bx plus c equal to e raised to x upon a square plus b square into a sine bx plus c minus b cos bx plus c. Similarly, integration of e raised to ax cos bx plus c equal to e raised to x upon a square plus b square into a cos bx plus c plus b sin bx plus c. In the definite integral, if integration 0 to infinity e raised to minus ax sin bx plus c, we have direct value b upon a square plus b square at integration 0 to infinity e raised to minus ax cos bx plus c, that is equal to a upon a square plus b square. Now define the Fourier transform. Fourier transform of the function f of x defined in the interval minus infinity to infinity f of lambda equal to integration minus infinity to infinity f of u e raised to minus I lambda u du. So this is the Fourier transform if the function defined in the interval minus infinity to infinity. And the inverse Fourier transform of f of lambda, or moreover the Fourier integral representation of f of x in the interval minus infinity to infinity is given by f of x equal to 1 upon 2 pi integration from minus infinity to infinity f of lambda, note that this is f of lambda, this value here, into e raised to I lambda x d lambda. Now you can observe here this integration from minus infinity to infinity, also this integration from minus infinity to infinity, and then by using the properties of definite integral we can use here even and odd concept. How? But before to that we should know what is the even function, what is the odd function. So even function, a function f of x is said to be an even function if f of minus x equal to f of x for all x. Note that here the graph of even function is symmetric about y axis. You can see here the figure. This is the y axis, and whatever this graph is, same graph you can find here. It is symmetric about y axis. So by using this definition or by graph you can decide whether the given function is even or odd. So for examples, f of x equal to cos x is a even function. Why? Because f of minus x equal to cos of minus x, and we know cos of minus x is the cos x for all x, and therefore it is a even function. Similarly, f of x equal to e raised to x plus e raised to minus x, x sin x and x square cos x, these are some examples of the even function. Now define the odd function. A function f of x is said to be odd function if f of minus x equal to minus f of x for all x. Also you note that the graph of odd function is symmetric in opposite quadrant. You can see here the figure. So you can observe here whatever the figure in the first quadrant, same in the opposite quadrant, means third quadrant. Here also in second quadrant, same in the fourth quadrant, means opposite quadrant. Some examples are x cube. You can see here f of minus x means minus x cube, that is equal to minus into x cube. So therefore f of minus x equal to minus f of x, and f of x is odd function. Similarly, you can see sin x is an odd function. You can see the graph of sine function is like this. It is symmetric in opposite quadrant. You must note that f of x equal to e raised to x is neither even nor odd function, because e raised to minus ax, if we consider, which is not equal to e raised to ax, and also e raised to minus ax is not equal to minus e raised to ax, and therefore f of x equal to e raised to ax, or you can say simply e raised to x, is neither even nor odd function. Also you note that product of two even function is even function, product of two odd functions is even function, product of one even and one odd function is odd function. So you can remember by the plus minus sign also. How? For example, even function into even function you will get even function. Odd function into odd function, you will get even function. One even and one odd, that is equal to odd function. So here I am using the multiplication for these signs. So you can remember like this also. Also you remember there the property of definite integral, integration from minus a to a f of x dx, that is equal to 2 times integration 0 to a f of x dx if f of x is even function, otherwise it is 0. It means that that is equal to 0 if f of x is odd function. And now you define the Fourier transform for even function. So Fourier transform of even function f of x defined in the interval minus infinity to infinity as f of lambda equal to integration 0 to infinity f of u cos of lambda u du. And also the inverse Fourier transform of f of lambda, or you can say Fourier integral representation of f of x in the interval minus infinity to infinity for the even function is f of x equal to 2 by pi integration 0 to infinity f of lambda into cos of lambda x d lambda. For even function, you note that here you will get cos function. Now Fourier transform for odd function. The Fourier transform of odd function f of x defined in the interval minus infinity to infinity is defined as f of lambda equal to integration 0 to infinity f of u sin lambda u du. And the inverse Fourier transform of f of lambda, or moreover Fourier integral representation of f of x in the interval minus infinity to infinity for odd function is f of x equal to 2 by pi integration 0 to infinity f of lambda sin lambda x d lambda. It means that here you will get sine. If it is even function, here cos, and if it is odd function, here you will get sine function. So note that here actually we are doing f of x. By using Fourier transform I will get f of lambda, and by inverse Fourier transform I will get f of x again. If we combine both the things, you will get an integral representation, Fourier integral representation. Now you can observe here for the even and odd function, we are going to use the interval 0 to infinity, even though interval defined interval is minus infinity to infinity. But in the calculation part, I am using only 0 to infinity. In odd function also, you can observe here we are using in calculation part 0 to infinity. And that is why we are ready to define Fourier sine transform and cosine transform. One more thing here you can observe, which is nothing but in even function we are using cos, and in odd function we are using sine. And that is why I am going to define here Fourier sine and cosine transform. So here first Fourier cosine transform. If f of x is defined in the interval 0 to infinity, note that for cosine and sine we require now the interval 0 to infinity only. Then the Fourier cosine transform of f of x, which is denoted by, this is the notation, fc lambda, and is given by fc lambda equal to integration 0 to infinity f of u cos of lambda u du. It means that it is the same formula as the Fourier transform for even function, only change in notation, fc lambda. And the inverse Fourier cosine transform of fc lambda is defined as f of x equal to 2 by pi integration 0 to infinity fc lambda into cos of lambda x d lambda. Similarly, Fourier sine transform, if f of x is defined in the interval 0 to infinity, then Fourier sine transform of f of x is denoted by fs lambda and is given by fs lambda equal to integration 0 to infinity f of u sin lambda u du. And the inverse Fourier sine transform of fs lambda is given by f of x equal to 2 by pi integration 0 to infinity fs lambda sin lambda x d lambda. The same thing we can put in a table. If the interval is minus infinity to infinity, then Fourier transform is f of lambda equal to integration minus infinity to infinity f of u e raised to minus I lambda u du, and inverse Fourier transform is f of x equal to 1 upon 2 pi integration minus infinity to infinity f of lambda into e raised to I lambda x d lambda. But for even function, even though defined in the interval minus infinity to infinity, the Fourier transform is integration 0 to infinity f of u cos of lambda u du, and inverse Fourier transform is f of x equal to 2 by pi integration 0 to infinity f of lambda cos of lambda x d lambda. You can observe here the difference, here minus infinity to infinity, here only 0 to infinity, and second is 1 by 2 pi here 2 by pi. For odd function, if it defined in the interval minus infinity to infinity, Fourier transform is f of lambda equal to integration 0 to infinity f of u sin lambda u du, and inverse Fourier transform is f of x equal to 2 by pi integration 0 to infinity f of lambda sin lambda x d lambda. You can observe here in even and odd function we require interval only 0 to infinity and it contains cos only. For odd function we require only 0 to infinity and it contains sine only, and that is why we can define here Fourier cosine and sine transform. So if interval is 0 to infinity, then the Fourier cosine transform is fc lambda equal to integration 0 to infinity f of u cos lambda u du, and inverse Fourier transform is f of x equal to 2 by pi integration 0 to infinity fc lambda cos lambda x d lambda, and Fourier sine transform in the interval 0 to infinity is fs lambda equal to integration 0 to infinity f of u sin lambda u du, and inverse Fourier transform f of x equal to 2 by pi integration 0 to infinity fs lambda sin lambda x d lambda. Student, remember there by this diagram, tree diagram, you can remember whole unit, that is the Fourier transform. So let's see how Fourier transform of f of x in the interval minus infinity to infinity. So there are three cases. It means that when we want to find Fourier transform, you just split into three parts. You check that function is even function, function is odd function, or function is neither even nor odd function. So if it is a even function, then the Fourier transform is f of lambda equal to integration 0 to infinity f of u cos of lambda u du, and inverse Fourier transform is f of x equal to 2 by pi integration 0 to infinity f of lambda cos of lambda x d lambda. If it is odd function, then the Fourier transform is f of lambda equal to integration 0 to infinity f of u sin lambda u du, and inverse Fourier transform is f of x equal to 2 by pi integration 0 to infinity f of lambda sin lambda x d lambda. Note that this f of lambda is nothing but this value, means corresponding this value. And if function is neither even nor odd, then the Fourier transform is integration from minus infinity to infinity f of u e raised to minus I lambda u du. Here we require whole interval minus infinity to infinity, but for even and odd we are using only 0 to infinity. And the inverse Fourier transform in this case is f of x equal to 1 upon 2 pi integration from minus infinity to infinity f of lambda e raised to I lambda x d lambda. So you can observe here the difference between all these three cases. Also you can define, if interval is 0 to infinity, then cosine and sine transform. So Fourier cosine transform, which is denoted by fc lambda, and Fourier sine transform, which is denoted by fs lambda, is given by like this. Fourier cosine transform, same formulas you can use here. Fourier transform as well as inverse Fourier transform. It means that inverse Fourier cosine transform. Similarly, Fourier sine transform and inverse Fourier sine transform. Only change in the notation here, you change this f of lambda as fs lambda. So by this tree diagram, you can remember this whole unit easily. So let's consider some examples on it. Now consider one example on the Fourier transform. Find the Fourier integral representation of the function f of x equal to, it's 1 if mod of x is less than 1 and is equal to 0 if mod of x is greater than 1, and hence evaluate integration 0 to infinity sine lambda into cos lambda x upon lambda d lambda. Second, deduce the value of integration 0 to infinity sine lambda by lambda d lambda. And third, find the value of above integrals at mod of x equal to 1, which are points of discontinuity of f of x. Actually, this is one of the lengthy example because it contains near about 4 parts. Right? So in exam you will get only 1 or 2 parts, not more than that. So here first is the Fourier integral representation. Note that if the Fourier transform, then you have to find only f of lambda. If inverse Fourier transform, then you have to find f of lambda as well as f of x. And if Fourier integral representation, it means that you have to find both f of lambda and f of x. Once you get a Fourier transform and inverse Fourier transform, for example here Fourier integral representation, it means that here we have to find f of lambda as well as f of x. So to deduce or to evaluate the values, we need this f of x. So in other cases, only Fourier transform, find Fourier transform, you have to find f of lambda, but in all other cases you have to find f of lambda as well as f of x. So let's see how. So solution here, given function is f of x equal to 1 if mod of x is less than 1 and equal to 0 if mod of x is greater than 1. You note that here mod of x is less than 1. It means that it is the value in between minus 1 to 1. Same thing if mod of x is less than a. So this is the value in between minus a to a. Now here we have to check. So to find the Fourier transform, you always check whether the function is even function, odd function, or neither even nor odd. Then we can decide the formula for Fourier transform. So here by graph you can decide it. How? So you can see this is x axis, this is y axis, and here the origin, and here supposed to be 1 and here minus 1. So f of x, so definitely this is y equal to f of x equal to 1. So in between minus 1 to 1, because mod of x is less than 1, it means that in between minus 1 to 1. So here I am getting value of f of x is 1. So straight line. So everywhere it is 1 and remaining 0. So this is the graph of this function, and you can observe that this graph is symmetric about y-axis, and if graph is symmetric about y-axis, it means that that function is even function. So therefore f of x is even function in the interval minus infinity to infinity. As we know, the formula for Fourier transform, if it is an even function, so you write there Fourier transform of even function. You must know the formulas. So f of lambda equal to integration 0 to infinity f of u cos of lambda u du. So 0 to infinity f of u. So here this is f of x in between 0 to, here it is infinity, 0 to infinity. So you can observe here 0 to 1 it is a 1 and 1 to infinity it is 0. So therefore you split this interval 0 to infinity into two parts as integration 0 to 1 f of u cos of lambda u du plus integration 1 to infinity f of u cos of lambda u du. So this is your first example. You can write direct values also. So what is the f of u in between 0 to 1? It is nothing but 1. So 1 into cos of lambda u du plus 1 to infinity, it is 0, and therefore I am getting f of lambda equal to integration 0 to 1 into cos of lambda u. It means that cos of lambda u into du. So integrate this with respect to u. So I am getting sine of lambda u upon lambda, because it is with respect to u. Therefore lambda is constant. Limits are 0 to 1. So upper limit minus lower limit. So u replaced by upper limit minus u replaced by lower limit. So I am getting here, due to upper limit u equal to 1, sine lambda by lambda minus sine 0. And we know sine 0 equal to 0. And therefore I am getting here f of lambda equal to sine lambda by lambda. As we know, sine 0 equal to 0. So first part is Fourier transform. You can consider this example into different steps. Just like this Fourier transform is first step, inverse Fourier transform is second step, and evaluation, different evaluation. You can consider the different steps. So here the step number 1. Now the step number 2. Inverse Fourier transform of even function. As we know, it is f of x equal to 2 by pi integration 0 to infinity f of lambda into cos of lambda x d lambda. So put this f of lambda value here. So I am getting here f of x equal to 2 by pi integration 0 to infinity. This f of lambda means sine lambda by lambda into cos of lambda x d lambda, which is your Fourier integral representation. The same thing I can write as f of x equal to 2 by pi integration 0 to infinity sine lambda into cos lambda x upon lambda into d lambda, which is nothing but your Fourier integral representation. So this is your Fourier integral representation. Now what we want to prove? Evaluate. Here we have to evaluate sine lambda cos lambda x by lambda. So just consider it. Now step number 3. You just denote it as equation number 1. Because by using this we have to evaluate the remaining values. See there, this is our target. Sine lambda cos lambda x by lambda integration 0 to infinity. This, so you can see there, this is integral representation and it already have this value with the limits. So what is this? You just convert this in this side. So you will get the required answer. How? So from equation 1, I am getting integration 0 to infinity sine lambda into cos lambda x by lambda into d lambda equal to pi by 2 into f of x. Now what is the value of f of x? F of x equal to 1 if mod of x is less than 1 and equal to 0 if mod of x is greater than 1. So substitute this value here. So I am getting that is pi by 2 into here 1 and 0 when mod of x is less than 1 and mod of x is greater than 1. And therefore I am getting the first value integration 0 to infinity sine lambda into cos lambda x upon lambda d lambda equal to, it is a 1 into pi by 2 when mod of x is less than 1 and 0 into pi by 2 means 0 when x is greater than 1. So this is our first part which we want to evaluate. Now second part, you just consider that is the 0 to infinity sine lambda by lambda. Only sine lambda by lambda we want to find. So how? So here if I consider it is equation number 2. And here you consider the step number next, supposed to be 4th. Note that here I want only sine lambda by lambda. Therefore, this value I want 1. So, cos 0 is 1. So, x equal to 0 I can put, because I will not disturb this lambda value, because I need there sine lambda by lambda. Therefore, x equal to 0 you substitute in equation 2. So, here put x equal to 0 in equation 2. So, what we get? We get integration 0 to infinity sine lambda cos 0 is 1 by lambda d lambda equal to. Now, here x equal to 0. So, x is greater than 1 and here x is less than 1, or mod of x is less than 1. So, 0 value is in this case, right? You can see by the graph also. Where is the 0? Here the 0, x equal to 0. I am getting f of x means y is 1. So, that is why I am getting this value, which is in between mod of x is less than 1. So, I am getting that is equal to pi by 2. So, note that this value integration 0 to infinity sine lambda by lambda d lambda equal to pi by 2. Now, the next value is what? Find the value of above integral at mod of x equal to 1. Mod of x equal to 1. It means that here it's a points of discontinuity, right? Because here mod of x is equal to 1 means here, if we consider, or maybe the here. So, at these points we want that particular value. Note that here less than 1 I am getting this 1 and greater than 1 I am getting 0. So, now the step number 5, at mod of x equal to 1. So, note that at mod of x equal to 1, this integral value means above integral value means this is equation number 2 I want, and mod of x, it means that this is a point of discontinuity. So, this value at mod of x equal to 1 I want. So, how? Let us see. Integration 0 to infinity sine lambda into cos lambda x upon lambda d lambda, at which point here I want mod of x equal to 1, and that is equal to, it is a 1 by 2 f of x at plus 1 plus f of x at minus 1. So, here at plus 1 in positive side of this 1, so I am getting it is a 0. You can see here by the graph. Positive side, 1 plus means this side, 1 minus means this side. So, here it is 0 and here it is a pi by 2. We already have this f of x means that integral value, which is nothing but pi by 2 there. Here you can see it's a pi by 2, and therefore, what is this value? I am getting that is equal to 1 by 2. So, plus it is a 0 and minus 1 means this direction I am getting pi by 2. So, actually value of this at this is nothing but 1 by 2 into pi by 2, it is a pi by 4. So, 0 to infinity sine lambda into cos lambda x upon lambda d lambda at mod of x equal to 1 is nothing but pi by 4, which is your required answer. So, note that here to find the Fourier transform, you have to find only f of lambda, but before to that you must decide whether it is even function, odd function, or neither even nor odd function. So, corresponding formula you can use, and by using that evaluation of that integral, you will get f of lambda. Then inverse Fourier transform, you can use again the same, that if it is even then odd, then neither even nor odd, corresponding formula, and then f of x, you put this f of lambda here and you will get the Fourier integral representation or inverse Fourier transform. Sometimes there may be the examples just like this one, evaluate different values. So, definitely we need here the Fourier integral representation, and you just observe what actually we require. So, for example, in the first only integral value we required, in the second we required sine lambda by lambda it means that this value I don't require, so you just convert into 1 by using the value of x or different values of x. Similarly, the third one. Definitely in the next lecture we'll continue examples on the Fourier transform.